All right, hello, chemistry class. This is Mr. Mellinger. It's your first day of distance learning, the first official day, Monday, April the 27th. This is the assignment. It's posted in the module. I'm sure as you found it on day 44. Each day will have its own assignment and will be labeled as such. There will be 22 days for the rest of the school year. So what I'm going to do is provide you with an assignment. I'll provide you with the answers to most of the problems. A couple of them I'll expect you to be able to do on your own. And if you at least do all the problems that I do with you, you'll get a majority of credit on the assignment. But you should try to do the ones that I don't do for you. I need to leave a couple for you to do. So let's just look at the dates here. This is Monday, April 27th. This is due by next Monday. You should submit this through the Submit Assignment button on the Canvas site, right where you found the assignment. If for some reason you don't see that, I've had one student not see that button, then what you should do is take a photo of it. In fact, you take a photo either way, but take a photo and then email it to me. Be sure that the picture is clear and that I can read it. And read it means two things. It means the picture's close up enough that I can see the words, and that your writing is neat enough for me to be able to read it. So you might have to write a little bit neater, maybe even a little bit bigger than you normally would, because I have to be able to read it. If I can't read an assignment, I will enter it in the grade book as a 1 point out of 50. That doesn't mean you're stuck with that. You can resubmit it, but I just want you to know what that means. If you see that you only got 1 point, that means I can't read it and you need to resubmit it. If you see 0 points, it means you didn't submit it at all. And if you see something above 1 point, it means that that was the score that you got. Okay, so let's go ahead and do this. We've already done balancing equations, but it's been quite a while. So I ask that you watch the video that comes along with this module, this day 44. It's the very short video on balancing equations. So there's two methods, and the easiest one and the one that's kind of a beginner's method is called the box method. So let's go ahead and do that. So you simply draw a box, and you break out each of the elements like this. Here you have 2 oxygens, and here you have 2 hydrogens and an oxygen. You pick one of the elements to balance. You want to stay away from elements that appear more than once on the same side of the equation. Now, neither of these does that, but there will be a few in a few of the problems later on where that will happen. Just pick one of the elements to balance, and go ahead and add boxes until everything's in balance. So hydrogen is already in balance, so we're going to balance oxygen. There's 1 on this side and there's 2 on this side, so we need to add another box over here. Now you can't just add the O, you have to add the H's too. Okay, so now we have 2 O's and 2 O's here. But by doing that, we threw the H's out of balance. We now have 4 H's on the right and only 2 on the left. So that means you add a box to whichever, you pick the element you're balancing and add a box to the side that has the least of number of those elements. In this case, we need more hydrogens on this side. So now we have 2 oxygens on each side and 4 hydrogens on each side. So the way you do the coefficients is you just count how many boxes. So it's 2H2, there's 1 O2. Normally in chemical equations you don't have to write a 1, but I'd like you to do it. It just helps you when you're thinking about using the math that we'll be doing later this week. And then we have 2 H2s. Okay, so that's how you do the box method. For the standard method, you simply list your elements down below the arrow and you count how many. You have an H2 molecule is 2 hydrogens, and an O2 is 2 oxygens, and over here we have 2 hydrogens, and we have just 1 oxygen there. Okay, so hydrogen's in balance. So what we're going to do is we need to make this a 2. We need to multiply this by 2. So we're going to put a 2 here. So we scratch that and make that a 2. And that's good. But we've also, what we've done is doubled the hydrogens here. So you have to scratch that and make that a 4. You now have 4 hydrogens. So now the oxygens are in balance. We need to get 4 hydrogens on this side. So we put a 2 there. And 2 times 2 is 4. And so I have 4 hydrogens on each side, 2 oxygens on each side. And these are the coefficients. The reason I write them up above is there's times you may have to change them a second time This may not be the final coefficients that you're going to end up, but in this case it was. So you can just scratch those out and put a 1 there and put a 2 there. And of course you see you got the same answer as with the box method. Okay, I'm going to alternate which of the two methods I use for the next few problems. So for this problem here, I will go ahead and use the box method. So you have silicon and you have 4 Cl, so you have to write that 4 times. Okay, so that's how you would write that. Let me go ahead and explain these. You may be asking what these are. In chemistry, we're gonna deal with this subject later. It's not really important for doing what we're doing today. But in chemistry, there's 4 states of matter that we deal with. Liquid, just think of water. That would be a liquid. Water here is a liquid. That's an L, not a 1. It looks like a 1. It's an L. The other is solid. You know what a solid is. Your desk is a solid. You knock on your desk, it's solid. Gas is like air. It has nothing to do with gasoline that people put in their car. That's just a short name for that's a chemical compound called gasoline. Gas is a state of matter. It means unattached molecules that can just float around freely and don't attach to other molecules. So air would be an example. The oxygen and nitrogen in the air are a gas. The 4th one is aqueous, and that's a mixture of something in water. So if you take a glass of water, that would be considered a liquid. But if you put some salt in it and stir it around so that now you have salt water, even though it still looks like a liquid, it's not considered a liquid in terms of chemistry. It's a mixture of 2 things, a liquid water and the salt. That's a solute and a solvent. Again, we'll talk about this later, but that's called a solution. And it's called an aqueous solution. When you mix something in water, and we're almost always mixing things in water, at least at this level of chemistry, it's called an aqueous solution. So what HCl means is it means you took hydrochloric acid and you mixed it in water. So most of the solution is water, but small part of it is the hydrochloric acid. Okay, anyway, that just explains what these symbols are. You don't need to understand them today. Okay, what do you want to balance first? There's nothing that appears more than once on one side of the equation, so we can pick anything we want. Let's go ahead and do hydrogen. It looks easy. We have 2 on this side. We have 1 on this side. So we're going to draw another box there for HCl. Okay, now Cl's, we have 2 on this side. Hydrogens are balanced. Cl's, we have 2 on this side and 4 on this side, so we need 2 more to balance those. And as you're noticing, that's going to throw the hydrogen back out of balance again. You can't always predict how this is going to work, but there's many different paths that'll get you to the same answer. So now we got the Cl's in balance, but the H's are out of balance again. We have 4 on this side and only 2 on this side. So let's just draw a box here. Okay, so now chlorines are in balance, 4 and 4. Hydrogens are in balance, 4 and 4. Si is already in balance. And now that we've drawn that second box, we have 2 oxygens and 2 oxygens. So everything's in balance. So we go ahead, we have 1 box here. We have 2 boxes here. We have 1 box here. And we have 4 boxes there. And that's a balanced equation. In chemistry, you can never use an equation that's not balanced. You have to balance it before you use it. Otherwise, it's meaningless. Okay? It's like getting a recipe to say to make a cake, you need cups of sugar, flour, eggs, but it doesn't tell you how many. So just knowing cups of sugar, flour, eggs doesn't really help you make the cake properly. You have to know how many. And so that's what balancing an equation is. It's telling you how much of each of these compounds you need to get these compounds over here. Okay, the next one, I'm going to do that one using the standard method. So let's see what we got here. We got Hg, that's mercury. We have right here, we have O and an H, and I'm going to make a point about that in just a second. O and an H. Over here we have an H, so we already got that. PO4. Now you'll notice that PO4 appears as, that's phosphate, and you notice it appears as PO4 here and PO4 here, except you have 2 of them. So you can treat that, since it's not going to break up, the phosphorus and oxygens aren't going to break up, you can treat that like an element. You don't have to break it up into phosphorus and oxygen. Now, so a lot of times OH is hydroxide. That also does the same thing. It doesn't break up from one side to the other, but in this case it did. You don't see an OH on this side, so you had to break up the O and the H there. So I'm just going to treat the PO4, I'll put a parenthesis around it, and treat it like an element. It's PO4 with a little 1 after, you want to put it. This is PO4 with a 2 after. Okay, so let's go ahead, and we have mercury 1 on this side, 3 on this side. We have oxygens. We have 2 times O, so that's 2 there. And you have 2 times H, that's 2 there. But over here, you have another 3. You have 3 more. So 3 H's here, and 2 times this is 2 H's, so that's 5 H's. And then you have the 1 PO4 there. We go over to this side. We have Hg3, we already wrote that. Now we have 2 PO4s, so we put a 2 on this side. Again, just treat it, I'll even put this in parentheses, treat it like an individual element because it doesn't break up during this chemical reaction. And then the H's, you have 2 over here. And the O's, you don't count these because you already counted them in PO4, but you still have that O left right there, so there's a 1, okay? All right, this is the one I'm doing with you because it's a little bit trickier, a little tricky with the PO4 in it. Okay, what are we going to balance first? Let's balance the oxygen. So we have 1 on this side, 2 on this side, so we're going to make 2 there. And we're going to scratch that and make that a 2. In doing that, we now have 2 times 2 or 4 hydrogens, so we're going to change that to a 4. All right, so what else now? Mercury. Mercury, there's 1 on this side, 3 on this side, so we're going to put a 3 there. Okay, so the 3 mercuries and the 3 mercuries are now in balance. But now what did that do to our oxygen? We had 2 oxygens, and now we have to multiply that by 3, so we now have 6 oxygens there. And hydrogen, we had 2 plus 3 is 5, so this gets a little tricky. So now you have 3 times 2 is 6, plus 3 more is 9. So now you have 9 there. Okay, what else are we going to do now? Let's do PO4. We have 2 on this side and 1 on this side, so we're going to put a 2 there. That makes our PO4 in balance. But again, that changes our H. So you notice how many times the H is changing. You have 3 times 2 is 6, and 2 times 3 is 6. So that means we now have 12 hydrogens on the left side. Again, slow down, stop if you need to kind of pause and think about these a little bit, okay? This is a pretty hard problem, and so we're doing this one together. Okay. All right, so we now have 12 hydrogens on this side and 4 on this side. Well, we want to get 12, so I'm going to take away that 2 and change it to a 6. So 6 times 2 is 12. And now I have 6 oxygens there, so that's going to change this to 6. And so, hey, look what we have. 3 and 3 for mercury, 6 and 6 for oxygen, 12 and 12 for hydrogen, 2 and 2 for phosphate. They're all in balance. So our final coefficients are 3, 2, 1, 6. Okay? And you can scratch those out. Those are temporary. Okay, and that's how you do that. That wasn't an easy one, but you practice these and they become kind of easy. Okay, number 4. This is called a single replacement reaction. Just kind of throwing in some facts about this. You take a single element, and this is zinc in hydrochloric acid. We were going to do this as a lab in class, and unfortunately we didn't get there. This is hydrochloric acid. You guys all know when you put metal in an acid, it usually dissolves away, and this does. And what it does is the zinc replaces the hydrogen to become zinc chloride, and then the hydrogen goes off by itself to form hydrogen gas. And that'll form bubbles in the liquid, and if you put a balloon over the top of the flask, it'll cause the balloon to inflate. You would have seen that, but someday you will. If you take AP chemistry next year, you will see that. So that's called a single replacement reaction. You have one element replacing another, so the zinc swaps out with the hydrogen. Hydrogen never forms an atom by itself. You never just have an H atom. It's always H2 in gas. It's hydrogen always pairs up with another hydrogen in a gas. Okay, I'm going to leave that one for you to do. So I'm not going to do that one for you. I'm going to do the next one. Okay, let's go ahead and do number 5. I'm going to do it the standard way. The problem's a little bit harder than it looks. I have N, I have O, and I have H. As the 3 on this side, I have 2 N's. I have 1 O plus 2 more O's is 3 O's. And H2, I have 2 H's. Over here, I have 1 H, I have 1 N, and I have 3 O's. Okay. Now I say, good, O's are in balance. But the problem is they're not going to stay in balance because we've got to get the other two things in balance here. This problem's a little harder than it looks. I'll do it both ways. I'll do it with the box method in a second. But let me go ahead and do it this way. So nitrogen, I'm going to balance nitrogen first. So I'm going to put a 2 here. I have 2 on this side. So I'm going to put a 2 up here. So now I have 2 nitrogen. But I also doubled the hydrogen, so I now have 2 hydrogens. Well, that's good because now hydrogen's in balance. And I have 2 times 3 is 6 oxygens. So I changed that to a 6. So I have 6 oxygen on this side and 3 on this side. And I may say, well, that's going to be easy. You just double that. But you can't because you got 2 of the oxygens here and 1 of the oxygens there. That's what makes this tricky. So that's why this problem is going to be trickier than it might seem. So what do we do? Well, here's what I'm going to do. I am going to put a 2 here. So now I have 2 oxygens there, and I'm going to put a 2 here. So now I have 2 times 2 is 4, and 2 times 1 is 2. 4 plus 2 is 6. So now I have 6 oxygens on this side. But I threw hydrogen out of balance, because now I have 4 hydrogen. So I had to change that because I now have 4 hydrogen there. So I need 4 hydrogen over here, so I'm going to change this. Now you see why I write these up above, because you don't always keep them. Sometimes they have to change. I'm going to change that to 4 hydrogen. Now hydrogen's in balance. The problem is, and nitrogen is not in balance because now I have 4 nitrogen. So now I'm going to go ahead over here and put a 2 in front of this. So now I have 2 times 2 is 4 nitrogen. So 4 nitrogen, 4 nitrogen, 4 hydrogen. But I threw over here, when I put that 4 there, I threw the oxygen out of balance. Now I have 4 times 3 or 12 oxygen. Okay. So what do I do to get this up to 12? Well, I have 2 times 1 is 2, and I have 2 times something. I have 2 times 2 is 4, but this is going to change. And what do we do to get 12 oxygen? Well, I have 2 times 1 is 2, so I need 10 more. So what do I multiply this by to get 10? I need 5 more. Okay, so let's see if that balances. So what I did was I now have 2 oxygen plus 10 oxygen is 12 oxygen. 2 hydrogen times 2 is 4. That works. 4 nitrogen and 4 nitrogen. So it looks like everything's in balance. It's a little bit ugly, but there it is. I'll do this one down here using the box method. Maybe you like that better. Leave some space for this one. So I have N2 plus, get on screen here. If I'm ever off screen, just yell at your computer and maybe I'll hear you. Plus H2O goes to an arrow, and then notice that it's not always 2 on this side, 2 on this side. You kind of start to think that they're all like that, but they're not. Oops, no, that's HNO3. Okay, let's do this with boxes, and maybe you'll like that better, because this was tricky up here. N and N. Okay, again, stay away from the O's. They appear more than once on this side of the arrow, so stay away from them. Let's go with the N's. So I have 1 N here and 2 there, so I'm going to draw another one down here for N, but you have to draw everything else that's in the box. Okay, so N's in balance right now. H is in balance right now. O is not in balance. You have 1, 2, 3, 4, 5, 6 O's, and you have 3 on this side. So again, this is a little tricky even with the box method. Let's go ahead and add, let's see, if we add 5 more here, we'll have 5 times 2 is 10 plus 1 is 11. And then, let's see, so, okay. So let's go ahead, and we can't balance this just by adding there, because you have 2. Right now you have 3. If you add 2 more there, you have 5. If you add 3 more there, you have 7. you end up with these odd numbers and you have 6 there. So it makes this one a little tricky. So let's get this to be an even number first of all. H, H, O. All right, so now we have 2 O's, 2 O's. So now if we draw another O here, our O's are now in balance. 1, 2, 3, 4, 5, 6, 1, 2, 3, 4, 5, 6. But we threw the H's out of balance. So we need to draw another box here. You're going to see this one's going to make you a little crazy. I never give a problem this hard when I do give tests, so you don't have to worry about that. If we were having tests, but we're not. Okay, and I need another H. Okay, so let's look at what we have here. We have 1, 2, 3, 4 H's and 1, 2, 3, 4 H's. That's all good. We have 1, 2, 3, 4 N's and only 2 here. So let's balance the N's with 2 more. Now H's and N's are in balance. Now O's. We have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Okay, and we got 2 here. So let's add to this, because this doesn't throw anything else out of balance if we just keep adding O's. It keeps the H's and the N's from going out. They don't change, in other words. So let's keep adding these until we have 12 O's. All right, so 2, 4, 6, 8, 10, 11, 12. There's 12 O's on this side, 4 H's on this side, 4 H's on this side, 4 N's, 4 N's. So you got your answer is 2, 5, 2, and 4. Okay? All right, so I'm leaving you with 2 of these to do, numbers 4 and 6. They're not that hard. I can tell you the coefficients are very small here, and they're very small here, so it won't be too hard to do those. Okay, that'll be the rest of your assignment, and we'll see you on a new assignment. I'll try to get the rest of this week's assignments up in the next 24 hours or so. Okay, do the best I can. All right, have a good day.